Let's talk about conservation of energy, which will be a very powerful tool to solve many of the problems that we've already solved using work equals delta K and kinematic equations. So we start with the concept of work, which comes from F equals ma, and we know that we've already derived that this is equal to a difference in the kinetic energy, K final minus K initial. But now we can consider the possibility that the force comes from some function that is not a vector. So in particular, F dot dr is minus du. So it's a function du, and so when we integrate that, we get a minus u final minus u initial, or u2 minus u1. The function u evaluated at 2 points along this path from initial to final. So final initial, initial to final. So basically we're saying that du, this infinitesimal scalar, is minus f dot dr. And so there's an operation that takes this function, turns it into a vector, so we can get the force. If we look at this function, it's kind of like a du by dr gives us f, or minus f. So more rigorously, we have to do the gradient of that function, and that's what gives us minus f. We take the scalar function u and we turn it into a vector minus the force, where gradient of u in Cartesian coordinates is just the derivative of u with respect to the different components, du by dy, j hat and du by dz k hat. So we can see that du by dx is equal to minus fx, du by dy is minus the y component of the force, and du by dz is minus fz. And so to make it more practical, let's think of the force of gravity. So let's say that we have a coordinate system where the force of gravity is in the y direction, so fy is minus mg j hat. That's the force of gravity. So what we're saying here is that du by dy is equal to minus fy, so that's mg, just the component part. And so when we integrate this, right, we have delta u is equal to integral of mg in dy, and that gives us mg y final, right? We're going initial to final, y final minus y initial. We really should say y initial to y final. So these are subscripts. And so we say that this is u final minus u initial, and that's mgy final minus mgy initial. And so we can see that this is u final is mgy final, u initial is mgy initial, and so in general we've identified the potential energy, that's what it's called, function u, which is mg times the height y.